Okay, so something just to round off our lesson here in the inverse trig functions is actually to use a little bit of technology. Now, we are going to explore this much more in depth once we get into actually word problems in trigonometry and kind of like utilize this a little bit more. But the main important thing, again, that we're looking for when we're trying to find the inverse trig, which this whole lesson we were trying to develop, is you're looking for the angles, right? When I have like the sine of theta, and, sine of some angle, we talked about that equals the opposite over the hypotenuse, or that equals the y coordinate, or, we're just given some value like, 1/2. Again, it's the sine of an angle, right? And obviously we know that this angle is theta equals sine of 1/2. That's going to be, we could look at that in degree form. That would be, 30 degrees. So again, when we're looking into these forms, when we're using sine inverse, of 1/2, we are looking for the angle. That is what we are trying to solve for. So in here, we're going to have some missing angles, and I wasn't able to sketch these in, so I'll put these in there. So basically, the question is just use inverse functions to be able to determine the value of your inverse trigonometric of your angle, okay? So again, we know that, like in this example, we know that here, we can basically what we want to do is I first identify which trigonometric function should we use to identify the value of theta. Well, based on this angle, you can see we have the opposite as well as the adjacent. So what I can do is let's write a trigonometric expression. So we can say, tangent of our angle theta is equal to 5/6, right? But now, if we need to figure out what theta is, we need like kind of in this way, like sine of theta equals 1/2. Well, again, if we want to solve for theta, then we're going to use the inverse trigonometric function. So, you could take the inverse on both sides, and that's kind of one thing that we talk about, at the beginning of this class we looked at. If you have 3x, is equal to 6, you're dividing by 3. Why are you dividing by 3? Because dividing by 3 is the inverse operation of multiplication. So the inverse operation of taking the tangent is tangent inverse. And when you take the tangent inverse of theta, and again, you have to do it on both sides, right? Just like you had to use the properties of equality with division, you have to use the properties of equality with tangent here. Oops. You would get, let's put this in parentheses, 5/6. So again, what that allows us to get now is theta is equal to tangent inverse of 5/6. So now we need to figure out what this is. And unfortunately, this isn't, we don't have we know this isn't a point in a circle, so we're going to have to use our calculator. Now, I didn't say what we should round to, so, or if I should round it or truncate it. So now what we're going to do is just use our technology to go ahead and figure this out. Now, come on. So what I'm doing is using Desmos scientific calculator. Obviously, I know some of you use a graphing calculator and, looking into some different software that we could use. I decided on this would be the easiest as far as to kind of teach from. So I'm going to kind of put this up here. There we go, hopefully. So basically all we're going to use now, the main important thing when you're doing this with the calculator and trig, and this is very important, is make sure you're in degree form, right? When we're dealing with our angles, or if we're trying to find the angle, we want to make sure we understand, are we trying to find the angle in terms of radians, or are we trying to find the angle in terms of degrees? And in this case, actually, I didn't even label this, but I'll fix it. Yeah, so we're going to want to make sure we know the directions, and I did not clarify. So usually, though, I clarify is to find the angle in degrees. All right. Now, anyways, one thing we kind of know to like kind of spot check, we can do this. If the two sides were 5 and 5, then we know it'd be a 45-degree triangle. So since they're like pretty close to each other, I know I'm like going to be pretty close to an angle that's like right around probably like 40 degrees. So let's just go and check. So we're in degree form. We're going to go to our function, and I'm just going to type in tangent inverse, and then just do 5 divided by 6. And then obviously you can just go ahead and, move it over, and close this out, and you can see that, hey, I wasn't too far off, 39.8 degrees. So I usually like to round this to the 32nd, oops. I like to round this to the 3rd degree here, or 3rd decimal place. So that'd be 39.806. right, so we'll write that as 39.806 and then in degree form. So I forgot to write your angle of the given triangles. Let's write that in degrees. Okay, so now in this triangle, we're going to do kind of the same thing, but now we realize that we don't have a tangent relationship with our angle theta. Now we have the opposite side and the hypotenuse. So I'm going to want to use the sine function. So I'm going to say sine of alpha is equal to the opposite over the adjacent. So hopefully you can see now to evaluate for the inverse, I'm just going to say theta is equal to sine inverse of 5/6. So I'll go back to my lovely calculator here and delete that. So now I'll use the sine inverse function, and I'll now just do 5/6 again, going back to the same angles, obviously. And you can see now this one is 56.443 as it gets rounded. So I'll write that. And since I'm rounding, well, I actually asked to approximate that, so I can write that as in the rounded answer. So rounded is going to equal, crap, I forgot the 56.443. Okay, so again, obviously you could say in the approximate, if looking into the rounded, if you're looking into an approximate answer or kind of rounded it here, I'm going rounded, so therefore I'm going to say that equals into the rounded value, and I'll change that as well, because that's exactly what equals rounded. Obviously we know that's not the exact answer though. And then this last one, you can see that I am dealing with the cosine relationship of angle beta. I have adjacent over hypotenuse, so I'm just going to go ahead and write this as cosine of beta is equal to adjacent over hypotenuse. So beta is equal to cosine inverse of 5/6. So again, we just go back to our calculator here. And let's actually change it right there. Cosine inverse, and you can see that's 33.557. 33.557. And I forgot, these are in degrees, ladies and gentlemen, so make sure that you're using the correct notation with the degree symbol, okay? Because we wanted to find the angles in degrees, which I made sure I clarified, which I forgot to write in there. But ladies and gentlemen, that is it for the inverses of functions. Hopefully now that you can see that we can work with the inverses of functions, dealing with them when they, in regards to how they look in a triangle, and using technology. Also, when we have an algebraic expression, when we have points that are not on the unit circle, and then obviously doing the composition of our inverse functions with our regular trigonometric functions, and then evaluating the inverse functions based on the unit circle. So that is it for our chapter on trigonometry. Look forward to you guys on the next one. All right, cheers.